Hello everyone, my name is Timothy Lee Grant, and look at the time up here. It is January 1st, so Happy New Year to everyone. Alright, I was thinking, New Year's, what a perfect time to do some backtracking. So let's do a backtracking problem. Alright, so I was thinking, let's just pick the first backtracking problem here. It's a medium. Let's do that one. Woo, make myself real big. No, let's not do that one. Let us do number 17, combination of a phone. Let's see if we can solve it. All right, letter combinations of a phone number. All right. Given a string containing digits 2 to 9 inclusive. All right. So we're not going to be using this 1. We're just doing 2 to 9. We're also not using 0. Return all possible letter combinations that the number could represent. Okay, so I remember when I first learned backtracking a long time ago, maybe like 3 months ago or something like that. One of the triggers in your brain that you should listen for is whenever you hear those words return all or all combinations or all something something something, your brain should automatically start thinking like, okay, this sounds like a backtracking problem. So that's one of the important things that in this example we knew that we were selecting out of the backtracking kind of bin, right? So we knew that it was going to be a backtracking problem, but all right, how do we actually train that light bulb to that little identifier to be like classifier? It's a classifier. Here we go. This uh, real neural network classifier to be like, hey, these keywords make me think backtracking. And that is one of the things that we need to recognize is all possible combinations or all combinations, all something. All right, so anyways, we have this pad. It has 2 to 9. Those are the valid numbers that we're using. Return all possible letter combinations that the number could represent. Okay, return the answer in any order. Okay. A mapping of digital to or digits to letters, just like the telephone button is given below. One does not map to anything. So we're given the mapping between 2 and like ABC, 3 and DEF. Okay. So the input, we're going to be given some string like 2 3 or 5 6 or 5 8 2 1 9, something like that. And we need to create a list, and in that list we need all of the combinations which all of the letter combinations that could be. So like for example, if someone just inputted a 2, well, what combinations would we need to have in our list? We would need to have A, because that press could have been an A. We need to have a B because that press could have been a B, and we need a C because 2 can also be a 3 or a C. If they do 2 5, we need A J, A K, A L, B J, B K, B L, C J, C K, C L. So we need all of the combinations, and each of those are going to be a separate element in this list representing the combinations. So, how do I want to start doing this? Obviously with backtracking, I know that we need some kind of like helper function. So def traverse, okay. And what do we want to traverse on? I'm not quite sure yet. So, I have this input, which is strings, and that is going to be the specific digit. Can I have some way of like mapping a digit to the letters? Would a dictionary? No, I don't think a dictionary would work in that specific case because it's not a key and a value. It's a key and 3 values, and I need to iterate through each of those. What I might be able to do is like create a list for each of them. So like 2 equals and then a list, and have A, B, and C. So I'm just creating a list of strings for each of these letters. And then somehow in my backtracking traverse function, I'm going to iterate through all of these elements for each input. So, okay, it's a little bit fuzzy right now, but I'm going to try to 3. I have some lead. I don't know if it's right or not, but we'll see about this. 3 is going to be D. And then E and F. Okay. 4 is going to be a list with G, H, and I. Okay. 5, a list, and it's going to be J and K and L. It's going to be a little bit unfortunate if this is not the right path and I just waste a lot of time just doing these, like creating this little list here. So 6 is also going to be a list, and we are going to have M and N and O. Okay. 7 is, surprise, surprise, a list, but with 4 in there. All right. So we have P and Q and R and S. All right, 2 more to go. 8. Okay, T and U and V. Last one, 9. Okay, is going to be W and X. X and Y and Z. Okay, so we have a list representing all of the kind of the mapping between the number and the letters that it could represent. So now I am going to call this traverse function. So I'm going to go traverse. So I'm calling the traverse function, and what do I want to actually pass in? Digits, right? Or I already have access to digits from the traverse function. Maybe index. Okay, so index is going to represent the specific index that I'm at. In this digits. In this digits string. Okay. So let's see if I can work with that. Index. So index is going to, we're going to start at 0. Okay, and now what would be the base case is when we're done with the string, right? So if index is larger or equal to the length of digits is going to be length of digits, then we can return from that's our base case. All right. Now we want to we're at a certain index, like the 0th index. We want to look at that number, okay, in digits, and we need to store that number. Like, this is the number that we're trying to append. So how would I do that? Well, I could say, I can do like a char. Is that not a keyword in Python? That's weird. I thought char was a keyword in Python. We might have to go back. But anyways, I'm just going to assume that this does actually give the char. Oh, no, I want int. But I'm kind of curious now, like, why char didn't work. That didn't look like a keyword right there. So we'll have to go and try to refresh our memory later. So digits are characters. So digits indexed at index, and this is going to return a specific character, like the character 2, and then I'm going to make it an integer. Okay. But now I need to say, like, hey, this is the, like, I need to map it to one of these. Which now, actually, this does make it seem like a dictionary. Can I do something like my dict equals, and then something like this? I have no idea if that works. Like, can I just do this? And then what was the when I'm declaring a dictionary, how is it? It's like like I do this, right? And then my dictionary dot append, is it? All right, this is kind of a notation question, and we're wasting time right now, so this is not important to the algorithm. I'm just going to put it in GPT because that's perfectly fine to do. I want to declare a dictionary in Python with the var name as key and the list as a value. Okay, let's see if this might be helpful. Possibly. Okay, you're a pro. Whatever. Okay, so here's the notation. We have to use that like colon and then a list of all of that. So how is it? And then each of these is kind of like this. So like that. Okay. And now I need to do this for each of them. I'm still not entirely sure how to iterate over each of the elements in a dictionary. So again, this video is definitely going to be good practice to figure out like how to do all of this. So I think we declared this dictionary. Okay. Now I need some way to actually, now that I think about it, what if I just did something like this? And I should copy and paste this. Okay, so copy, paste here. Now, instead of 2, I have the character 2, I have the character 3, I have the character 4, likewise 5, 6, 7, 8, and 9. So now I have this value, or I have this key, and this is actually going to give me a char back. So I can just index it like this and get that list back, right? So iterables, I'll call it, maybe iterables equals my dict indexed at digits index. So this, I'm going to put this down below just to save my work, but get it out of the way. Okay. So this right here is going to evaluate to whichever index we're at. So like it's going to be this 1, that's going to be index 1, and then it's going to evaluate to the char 3, and then I'm passing that into my dictionary as the key, this character 3, and then I'm going to get back this list of what 3 represents, okay? And that's going to be my iterables. And now what do I want to do? I want to go through each of those iterables and add it to my possibilities. So what I'll need to do is I have a string, right? Like I have a list, and I will have some letter combination. So like so far it is D, F, E. And now there's a new letter that I need to add. It's at, I will be needing to add this letter at this position. I'll need to add an M, right? Let's say that index is, or digits index is just a 6. Like this one was a 3, this one's a 2, this one's a 2. They didn't really give any larger numbers, but let's just say that it's a longer string out here and there's a 6 here. So we come to one that is a 6. Now what do I need to do? I need to add all of the possible values for 6 into here. So what I need to do is add an M right here and then keep going. I need to now go to the next index and add whatever came after this 6. And then when I get to this return, once I hit the length, I need to pop all the way back out. And now I don't need to add an M here anymore. I need to add an N. And then go to the next index. And then remove that N. And then add an O. So what I need to do is currently working dot append. No, I need to iterate through all of those iterables. So for letter in iterables, I want to add that letter to currently working. So currently working append letter. Okay, and then I want to traverse at the next index. So traverse index plus 1. So I'm moving to, if I start at 0, I am first going to add an A, because that's going to be the first iterable here. So I add this A into currently working, and then I traverse to the next index, which is 3. And now 3, I add a D, because that's going to be the first iterable in digits of 1. 1 is here, of digits that evaluates to this 3. Pass in 3 to this dictionary here, and the first letter is D. So then I append D to currently working. Now it's AD. And then I traverse to the next element. Okay. And then we're out of bounds, and now we need to add this combination, this string combination, to our answer list. So here's a list, which is an answer list. Okay, so answer list. Answer equals empty list. So I need to do append and then currently working. Okay. And then I can return. So currently working is going to just be an empty string initially, and then we're going to keep adding things. Now that I've added this D, I now need to, I'm going to pop out of here, and I just added everything. I just added everything and got out of bounds, and then put this AD into the list, but I still have AD in currently working. I now need to remove that D and go to the next iterable. So I need to remove the one that I just added. So currently working equals, how do you do that with a string? Currently working slicing 0 to let's see, so want to remove the one that we just added. So it would be length of, would it be index plus 1? Or just index, I think. Index plus 1 because this one is not inclusive, right? So we would take away that. And so if we're on, let's say if there's 3 letters in here, so it's 2, 3, 4. So we're on this. So index is 1. Index is 1, yeah. And now I want to, I'm going to be adding and subtracting this at index 0, 1. So I want it to be non-inclusive. So I think it should be like that. 0 to index. And then come back up, add another letter, and then keep doing this. Is that... Return answer? I'm very unconfident about this one. But let's try it. Oh wait, I thought they said that we could do this. Cannot assign a literal here. Oh, it's because we didn't do the colon. Okay, so let's try this now. Let's see if this works. Again, that one was a syntactic error. I'm more doubtful on the actual, like, append. It doesn't like this append to currently working. Currently working plus equals letter. Does that work? Right, because this is a string and I'm just like adding a string. No, it doesn't like that. Okay, that's another syntactical thing. So how can I add a letter to a string, then remove a letter from a string in Python? So this is kind of what I mean, like LeetCode definitely does teach you like how to make sure that you're pretty like good at all of the syntactical stuff with Python, because it just like destroys you if you don't. So new string equals, so you can do plus. Position to remove, original position. Adding a letter. Okay, so you can just use the plus. So why did this one not work? So letter is not associated with a value. In iterables. Is this like some weird thing if there's no digits? Like, if not digits, return an empty list. Is it some kind of strange thing here? No, it's not. Currently, so why would letters be or why would letter be what, undefined? Not associated with a value. Oh, and I also realized I need like non-local answer, non-local currently working. I don't know if that's the problem. I don't think it is. Huh? That was the problem? And it was accepted? Hey. Hey. Here we go. Okay. Okay now. That's pretty nifty. I wasn't I wasn't necessarily even expecting it to actually work. Um so I can explain a little bit more of like what I was doing. Now that I'm filled with a little bit more confidence in my answer. um which is all right, so I take then this digits, which is 2 3, right? So it's a string containing 2 and 3. The letters 2 and 3. Then what I do is I go through each of the index. So I first start at index of 0, and I come here, index is 0, and then I see, am I at the end of the string, of the digits string? No, I'm not. So then I come and I figure out which letter, or number, sorry, which number in the digit string I'm working with. So right now, it's 2. Okay. And so then I see, like, what are the letters that are associated with 2? That's how I'm doing this dictionary thing. 2 is associated with A, B, and C. So now my iterable has A, B, and C in its list. Okay, so then what I do is I say, okay, I'm going to iterate through all of the combinations that this iterable is at this specific index. So, but what I need to do is I need to add the first one. Then I need to go to the next index, which is 3, because we need to add this A, that's part of this 2, and then I need to go to the next index, which is 3. So I need to add D to this currently working. And so this is why I call backtracking kind of like you have a sticky variable. So currently working is our sticky variable, where we first stick on an A, then we stick on a D here, and then if there were more digits in the string, we would stick on more, and then at the end of that sticking, we built some character, uh, like, I don't want to say set, because whenever you talk about like computer science, every single word that you say can mean something very specific. So if I say a set, computer science actually has a very specific meaning for what a set is. So each like a word, right? Each word, we have a word, and now we need to add that word to our answer. So we add it to this list. So we come here and we get this. The first one is A. Then we go to the next one, which is here, and we look at 3. And now 3, the first one is D. So we add that to our sticky variable. And then we come here and it's out of bounds, and we say, okay, well then this is one valid, this right here is one valid word. which is currently working, our sticky variable, has one valid combination, we need to append that to our answer. And now we pop back out. This was just out of bounds. We just put index plus 1. It was out of bounds. We added our currently working, our sticky variable, into the list. And now what we need to do is say, okay, well, actually, I want to take away the letter that I just added. So right here we added D. So we take D away here. Then we come up to the next for loop and we say iterables, which, remember, now we're on the number 3 right now. So our current thing is D, and then we go to E. So now, currently working, we just took away D, and now we want to add E. We want to add E. So we add E to currently working, and we try to go to the next index. It's going to be out of bounds, and so then we add currently working, which is AE, to our list right here. Okay, then we pop out and we're back to that 3. We remove E from currently working. Now currently working is just A. We come back up here to iterables, and what's this one going to be? It is going to be F now. So then we add F. We try to go to the next index. F is out of bounds, and so we add a F to our currently our answer list. And we pop out of that. And then we remove that F. And then we come here because we're done with 3. We've hit D, E, F. So then now and this is kind of the backtracking thing. So we return from here, right? We return from this traverse function and go back to the calling function. What was the calling function? It was the original one when we said index was at 0. So now we're back here at index 0, and we just added A to currently working. And as of right now, currently working does contain A. So then we remove A. Index is 0. Okay. Then we come back up here, and iterables, we're not on this 3 anymore. We are on this 2. So now we're looking at B. So then we get B here. We add B to currently working. So now currently working, we had A, and then we took it away. Then we came up here to the next iterable, and now we add B. So now it has B in here. Then we go to the next index, which is going to be, we're at 0, so now we go to 1, index 1, which is 3. So now we do the exact same thing over again. We come into here, traverse at index of 1. Come here, we're not out of bounds. We look, index is 1. Digits at 1 is 3. We put that into 3 into our dictionary, and we get this iterable. Okay, then now we iterate through D, E, and F. So you can see how we're going to now create. I said we first added, what was it, B into currently working. Now we're going to get B, D, B, E, and B, F. So that's B, D, B, E, and B, F. And then we remove this one, this B, we pop back out, return from here, and then we are going to go back to the calling function here, which is what? We're going to go to C. So it is, we're going to remove B, and then come back up to here and we're currently at the 0th index, and then we're going to add C and then do the exact same thing over again. So I think that with these backtracking problems, they are very much of a mind bender. What kind of helped me with them when I learned them 3 months ago was, or maybe 4 months ago, I can't remember when, to think about this like sticky variable, and then at the end of something, you are going to take that sticky variable and save it because you want all combinations, and you found one combination, and that sticky variable holds track of those combinations. So here's our answer, like save point, and then here's the sticky variable that you add and then subtract things to as you pop in and out of the uh, uh, recursion functions. And then the other thing that you need to think about is just like, what is the base case? Like, when do you actually say, hey, that sticky variable, it's finished, it's done, add that to the answers. So if you kind of like just I think with me, I had to say, I am not going to look at anything other than backtracking. I am not going, and I mean, I'm not going to look at my phone. I'm not going to look at Instagram. I'm not going to look at, I'm not going to go talk to my friends. I'm not going to hang out with my friends. I'm not going to, which that one's pretty easy because I don't, after I started working, I just like don't, uh, I've like zero time to hang out with anyone. So it's like that one I was already doing, but I mean, like I didn't think about anything other than backtracking. And I didn't watch random YouTube videos. Every YouTube video I watched was about backtracking. And I said, I will get this. And I focused on it, focused on it, focused on it, focused on it. And then like 3 days later, something in my brain just clicked. And I did like maybe 2 months where I couldn't solve any backtracking problems, any at all. And then all of a sudden, it just clicked, and I was like, I was able to kind of go through and solve some problems. And I was like, oh, actually, this is kind of cool. So that's kind of how I would suggest going about it. But yeah, I'm pretty surprised that it worked. That's cool. Awesome. So yeah, thank you guys for watching these videos. I hope you enjoyed it. If you would like, subscribe to this channel. That would be great. And I will see you guys tomorrow with another LeetCoding video. Um, my work starts tomorrow, so it's January 1st. My vacation is over, so back to the grind, back to working. But that's not going to stop me. I'm going to continue doing LeetCoding videos, keep practicing and improving my skills. So we're gonna not give up. We're going to keep moving forward. So thank you for watching, and I hope you have a wonderful day.